Hello everybody, and on this PowerPoint we are going to be looking at a tour of the solar system. So we're going to be taking a tour, looking at different components of the solar system from our sun to our various planets, their moons, comets, asteroids, meteorites, and a lot of other stuff. Right, so here's a basic outline of our solar system. Notice it says Mercury, Venus, Earth, and Mars are the inner planets. They're also known as the terrestrial planets. We'll talk more about those in a little bit. And Jupiter, Saturn, Uranus, and Neptune are the outer planets, and those are known as the gas giants, also known as the Jovian planets. Right? And also in this diagram, it's not showing perfectly, but there is a belt of asteroids, which you guys know as the asteroid belt, which is a ring of rocks that orbits between Mars and Jupiter. So let's get started. Starting with the sun is obviously the star at the center of our solar system. We believe that our sun is about 4.5 billion years old, and it is basically just a huge ball of gas, specifically hydrogen and helium. Right? The way the sun produces its energy is through a process known as nuclear fusion, in which hydrogen and helium gases are basically, as the name suggests, going to fuse together and release energy in a complex nuclear reaction. On to the first planet. Mercury is the closest planet to the sun and is very similar in size to our Earth's moon. Now, if you notice, there is almost no atmosphere on Mercury, and that explains why temperatures can get as high as 467 degrees Celsius and as low as almost negative 200 degrees Celsius. Now, this is because there is no atmosphere, once again, to trap the heat or hold in the heat during the nighttime. So if the sun is not shining on the surface, there is nothing to hold that heat. It is lost. It is extremely cold on the dark side of Mercury. Now, if you also look at Mercury's revolution, it only takes about 88 Earth days to go around the Sun once. That is obviously because it is so close in proximity to the Sun that 88 days is obviously much shorter than our Earth's revolution of about 365 days. However, if you look at Mercury's rotation, it takes about 58.65 days to complete one rotation. So on Earth, it takes about 24 hours for one rotation to be completed. Mercury, that is obviously a very, very slow rotation. On to our second planet, Venus. Venus is going to be a very, very unique planet. It's very, very unique for a couple of reasons. The first reason is Venus is also a planet that rotates incredibly slow. So slow that it actually takes a longer time for Venus to complete one rotation than it does to complete one revolution around the Sun. So technically, a day on Venus is longer than a year, a very complex phenomenon to understand. Another cool thing about Venus is that it has an extreme greenhouse effect. Its atmosphere is a lot of greenhouse gas, such as carbon dioxide, which does a phenomenal job in trapping in heat. Because of this extreme greenhouse effect, the average temperature of Venus is going to be around 450 degrees Celsius. That is obviously going to be hotter than Mercury. It never gets cold on Venus. The heat is going to be trapped in incredibly well because of that greenhouse effect. Right, the Earth is the third planet from the Sun. Obviously, Earth sustains life as we know it. Water can exist in all three states, solid, liquid, and gas. And obviously, most of our planet is covered by water, about 70% covered by the ocean. If you look, rotation takes about 23 hours, 56 minutes, and 4 seconds, and revolution is about 365.25 days. That 0.25 is very significant because that is why we have leap year every 4 years. We need to account for that extra 0.25. If we don't, then our calendar runs the risk of getting messed up, meaning July 5th might not be the same position around our orbit as it meant 100 years ago if we did not account for that extra 0.25. Right? The moon is another important component of the Earth. That is our only satellite. The moon, once again, very similar in size to Mercury, but the moon also has no atmosphere, so very different from Earth. No water, no atmosphere. That's why you can see all the impact craters, nothing changing the surface, getting rid of them like you would see on Earth. Also, the moon is a lot smaller than Earth, so it has about 1/6 the gravitational attraction or the gravitational pull. So when you see astronauts on the moon, they're easier to move around. can bounce up a little bit or jump around in a sense. Not that there's no gravity, it's just a lot weaker than that on planet Earth. Right? It takes about 27 days for the moon to orbit the Earth once, and it takes about 29.5 days for the moon to show all of its moon phases, which we'll talk about later in the course. On to the fourth planet, we have Mars. Mars is the red planet, has the really red color to it because of the iron oxide in its soil. Recently, we have found evidence for ancient water to exist on Mars, so we believe that water did in fact once exist in some form on this planet. Mars has some very cool geological features to it. It has canyons that are way bigger than the Grand Canyon on Earth. For example, canyons on Mars, the biggest one we believe extends from Los Angeles to New York, about 3,000 miles across. So that is an extraordinarily huge canyon compared to that, a Grand Canyon like you would find in Arizona. Another interesting fact about Mars, not only does it have has an extreme canyon to it, but it also has an extremely tall mountain, the tallest volcanic mountain in the solar system. Once again, making even the tallest mountains on Earth seem very small in comparison. After Mars, that completes our rocky planets or our terrestrial planets, which are our first four, and we're on to our gas giants. And our first one is Jupiter, which is our fifth planet from the Sun. Jupiter is our largest planet, and it has the strongest gravitational attraction to it, which gives it over 60 moons. Right? Now, because Jupiter is so far away from the Sun, it is going to have an average temperature of negative 100 degrees Celsius. Yeah, very cold, and it rotates extremely fast, only a matter of hours for Jupiter, such a large planet, to spin around once on its axis. Due to this rotation, we believe that there's a giant red spot, or that giant red spot is a huge storm system on Jupiter, and you can see the dominant wind belts by just looking at its structure. Very interesting planet to say the least. Next, we have Saturn. Saturn is probably the most recognizable planet in the solar system because of its ring feature. Ring feature is made up of gas, dust, ice, lots of other things. Just like Jupiter, Saturn, gas giant that's very large, and it has about 60 moons as well. All right, so not as many as Jupiter, but close in comparison, especially compared to the rest of the planets in the solar system. Unique thing about Saturn is that Saturn has a density of around 0.7. So if you placed Saturn in a bathtub big enough of water, it would be able to float, the only planet that could claim such a thing. The next planet is the seventh planet out from the Sun, and that is Uranus. Uranus is actually tilted so extreme that it's basically lying on its side. So this right-hand part of Uranus over here, that's be like the North Pole, and the left-hand part, that would be like the South Pole. So it's basically lying on its side, right? Uranus gets its color, the blue color, because its atmosphere has some methane in it. Methane does a great job of absorbing the red end of the spectrum, of the color spectrum, and reflecting the blue end. So you're going to see a lot of blue color, very similar to Neptune, which we'll get to next. Right? Uranus, a gas giant, still very large compared to Earth. Its volume is about 50 times that of Earth, and it has 27 satellites or moons. Neptune, that's the farthest planet from the Sun, or the eighth planet out from the Sun, and it has that beautiful blue color because of all the methane that is in its atmosphere. Like we said, methane reflects blue of the color spectrum and absorbs red, so you're going to see what is reflected back to your eye, which is the blue light. It has also a little small system of rings and some dark spots where hurricane-like storms appear. So Neptune is believed to be very windy, a very windy planet. Once again, gas giant, so it's very large, about 44 times the volume of Earth, and it too has plenty of moons, about 13 moons to be exact. Moving on from our planets, some other features we have in the solar system. We have asteroids. Asteroids are either rocky or metallic objects that orbit the Sun. They are too small to be considered planets, but are sometimes called planetoids, so basically like a dwarf planet or a very small planet of sorts. Right? They can be anywhere from the size of a pebble to up to about 600 miles in diameter, which is pretty significant. They have been found inside of Earth's orbit and all the way out past Saturn's orbit. However, most asteroids are located in the asteroid belt, which exists between the orbit of Mars and Jupiter. So seen here, In between orbit of Mars and Jupiter, you have these collection of rocks known as the asteroid belt. Some scientists believe that this asteroid belt was a failed rocky planet, meaning that all this rocky material would have came together via gravity to create another rocky planet, but Jupiter's intense gravitational attraction due to its size and the sun's obviously incredible gravitational attraction were basically fighting each other and caused this to never come to. So for now, we have an asteroid belt full of tens of thousands of asteroids between Mars and Jupiter. In addition to asteroids, we have comets. Comets are going to be small, irregular shaped, basically balls of gas, frozen gas, that are going to orbit the sun. They uniquely orbit the sun in a very elliptical or oval shape. So they're going to get really, really close to the sun and really, really far from the sun as well. The unique thing about comets is that they have a tail. That tail is actually a product of the sun's solar wind. So the sun, think of it like a table fan, is going to emit a solar wind, and that solar wind is going to push ions and dust and debris off of the comet, and that comet tail is always going to go in the opposite direction of where the sun is located. So as you see here, the comet's tail is going up, and if the comet continues in its orbit over towards the left here, then the comet's tail will go towards the left side opposite of the sun. So the comet's tail always opposite of the sun and its solar wind. Lastly, we're going to look at meteors, meteoroids, and meteorites. Basically, these are all similar things. They're just named differently based on their location. So meteoroids are similar to an asteroid, but they're much smaller. They're more the debris of asteroids and comets. A meteor is what we call them when they are basically in our atmosphere burning up because of the friction interacting with all that air. So sometimes we call them shooting stars. Meteors obviously are not shooting stars. They're nothing to do with a star, but we just call them that. And that's because they're burning up as they pass through our atmosphere. And lastly, a meteorite is what is left from the meteor or meteoroid that strikes Earth's surface, that whatever does not burn up in our atmosphere. Right? So technically, what caused the dinosaur extinction, it wasn't a meteor, but instead that of a meteorite. You guys enjoyed the tour of the solar system, and that's all for today.